Yes.
Okay, sounds good. So I just wanted to go some brief tutorials about like Python basics. This notebook was initially prepared by Matthew Blondell, I believe a software engineer at Google. He wrote this notebook with a lot of like different, like very basic programming bits. And then later on, I do start talking about slightly more advanced topics such as class and objects, as well as adding some NumPy as well as pandas introductions, just because these data types or these objects are going to be quite important. So we're going to be going through some very basic Python basics. If you already know Python or you're well-versed in libraries, feel free to not need to actively tune in. I am going to be going through these very quickly. And then I'll also very briefly go over Intro to ML's Assignment 1. And Assignment 1 is actually probably the most simplistic version of like creating a model and like some very, very basic data engineering in order to fit data into a means of which can be interpret and input into a model. So we'll be going through both of these today. And with that, let's get started with the Python basics. So for those of you who don't know what this interface is, let me just move some Zoom windows around. This is Google Colab. And so we're actually running all of this inside of a web browser. How Google Colab works is that you can essentially up here, click connect, and you'll be connecting to a Google Compute backend of which you're going to be running Python code through Google's servers. So this allows us to have a very quick way of like running Python code without needing to install Python onto your computers. So anything that you do on Google Colab will actually be run on Google's servers. The reason why I want to talk about this first before getting into the Python programming is because, interestingly, you can have runtime types and hardware accelerators. You can see here both a graphics processing unit as well as a tensor processing unit for your hardware accelerators. And the reason why this is going to be important is that for people who are essentially either working on laptops or desktops that don't contain NVIDIA graphics cards, you will want to use Google Colab or some other service such as UTC supercomputer clusters in order to train your neural network models. The reason why is because graphics processing units as well as tensor processing units can be on the order of like 30 to 300 times faster than a CPU that you'll find in your laptop. And so training a neural network through these interfaces will be very beneficial in terms of like speed, or at least training speed. That being said, in order to use a TPU is quite difficult. And while there are tutorials for it, I'd recommend most people to stick to graphics processing unit training for neural network. But just know that with Google Colab, you do have the capability to use a graphics card if you don't already have one in your computer. So with that, let's get started with the Python basics. So what we're interfacing with right now are Jupyter notebooks, which look a lot different to normal software development kits that you may be aware of that only contain code that lives inside of a Python script file. So you can think of a Python script file as a text file that just contains code. When you run that Python script file, you'll use Python and it'll read that file. Jupyter notebooks are a little bit different because in addition to code, you can actually add things like text. And so I can even go so far as to add an image inside of a notebook or put bullet points such as this. The reason why notebooks can be nice is because of their ability to display smart outputs. So for example, I have here an example where it says seconds in a day, 24 times 60 times 60. It prints out here that it is 86,400. And I could also do this alternatively through that print statement, as you can see here. Now, the biggest difference between a GPacha notebook and a standard scripting environment, like say, for example, if you weren't coding in notebooks like say C#, is things like, if I scroll all the way down, things like smart tables. So notebooks can display smart tables if you're able to, or the library supports it. And in addition to tables such as this, you can also output directly things like plots instead of saving them to an image file. So for those of you who are already well-versed in programming, notebooks can be quite a bit different, but also convenient in terms of like development. So notebooks also have this like either convenient or inconvenient quirk of having to run cells. And this could be very useful in some senses or not useful in other senses. So say, for example, I have this piece of code. If I run this, it'll run this cell. However, if I go ahead and type print seconds in a week, we can see that it will basically error out because this variable, seconds in a week, hasn't been run yet. And so there are ways of which you can run things out of order that may be infuriating if you're used to a more standard programming environment. That said, once we run seconds in a week, we can run this again and it works just fine. For those of you who are quite new to programming, you'll know that what we're doing here is essentially variable assignment. So seconds in a day is a variable, and we have this very basic arithmetic, 24 hours by 60 minutes by 60 seconds in order to figure out how many seconds there are in a day, and we're assigning that to a variable. So Python basically supports all of your basic arithmetic options. You have 1 + 2, 3 - 1, 2 × 4, 5 divided by 2. 2 to the power of 3 is represented through double asterisk sign. So 2 to the third is 8. And we also have something you may not have seen before, which is 5 floor divided by 2. So as many of you know, 5 divided by 2 is 2.5. If we floor divide, we get 2. Because we essentially take the remainder out. This is regardless of whether or not it will round to that number. So say, for example, if it is 2.6, a floor divide will actually just remove the 2.6 without rounding it. And 2.5 rounds to 3, but we can see that it doesn't round in this scenario. The last thing that people may want to know is something called modulo. So as we can see here, modulo is essentially a remainder of a division operation. So if we do 5 divided by 2, that's equals to 2 remainder 1. And so as we can see here, 5 modulo 2 is 2 gets removed and it just returns the remainder, and the remainder is 1, as you can see here. So those are all of the arithmetic operations that Python supports. Are there any questions with anything that I've just said in terms of basic arithmetic and variable assignment for Python?
Dex, can you
Yes.
just share the link to the other people so that they can practice when they?
Sure. So that link is essentially in Networked Intelligence Lab. If you go into the repository, there's materials, and the materials are living and training in Python. So right here. Oops.
What I mean, the Google Colab link, the link that you are using, so that. Okay.
Right. So once you click on the Python notebook in GitHub, there should be a link that directs you straight into the Google Colab notebook in here. Though I guess if you want the notebook link directly, should be that. Okay, I'm guessing there are no questions. All right, I'll periodically be checking chat just to see if chat has any questions in there. So let's move along to something really important as we, in any programming language, but definitely for data science, as we'll be interfacing with multi-dimensional lists, the list type. So list is basically a container type for ordered sequence of elements. So essentially, if I want to store a bunch of variables in a list, I can define a list as 2 square brackets and then fill the list with some variables. This could be 1, 2, and 3. This could also be variables that are assigned. So for example, if I say my list equals 1, 2, 3, and seconds in a day, we can print my list. And we can see that now we have a list that contains 1, 2, 3, and the value of my variable, as you can see here. Lists in Python are dynamic in size, and so you don't have to set an initial size if you're used to other programming languages, such as Java, where you need an element size. List has a dynamic size, so you can create a completely empty list and continue to append values to this list. As we can see right now, or this output was generated before I added seconds in a day, but if we are going to append 4 to my list, we can see that now 4 is appended to the end of the list I defined earlier. We can access individual elements of a list through essentially a 0 indexed number. So what I mean by that is, as you can see, 2 is equivalent to 3 in the list, and this should still be the same, but that is because if we print my list as well as the indices, indices start at 0. So if I wanted to get the first value in the list, I'd have to get it from index 0. Oh, let me do print my list at 0. So I printed my list at 0. It gave me back 1. If I print 2, it gives me back 3, so on and so forth. An interesting thing to, an interesting way to access multiple values in a list is called slices. So with a slice, let's just run this really quickly. With a slice, you can essentially give 2 indices followed by, and in between those indices is a colon. And the first variable you get is the start of the slice, so 1. And the second value you give it is the end of the slice, so 3. Note that the end of the slice is not included. So as you can see here, 3 is 86,400, but we can see that it only took to end 3, 86,400 not included. If we wanted to include 86,400, we would have to change this to 4. And if we wanted from 1 all the way to the end of a list, we would just remove the number entirely. We would remove j entirely. So we now have 2 all the way to 4. This is true even for the opposite way, which is you start all the way from the start. So if I wanted to get all of the values except for the number 4 here, I could run my list colon to 4, And now I have 1, 2, 3, and 86,400. And the same thing is said right over here, I just realized. There are some common things or common functions that you could do with lists. So for example, you could say, you could ask, for example, if 5 is in my list, and this returns false. However, if I change this to 86,400, it'll say true. And then you can also get the length of the list, which if you are if you're aware of other programming languages, for loops, for example, will have to take list lengths, or commonly take lengths of the list if you're going to iterate through a list. So through Python, you can do it through the length function. Note that lists in Python don't have a property called length. You have to call the length function on a list to get the length. Some things that aren't actually talked about here that I think may be useful for everyone to know is also things like sorting a list. So for example, I could say my list.sort. And if I print, or if I just display my list, you can see that the original list, which was 1, 2, 3, 86,404, is now 1, 2, 3, 4, and 86,400. You can pass in a variable reverse and set that to true within the function. And you can see that now it has reverse sorted. And there are a bunch of other useful functions that you can call on lists. And if you'd like to know those, feel free to ask me or look at the documentation. Strings. So strings are ways to actually store text. They can be delimited using either single quotes or double quotes. For people who know other programming languages, this is a little bit different because chars or characters are usually defined in other languages as single quotes, but Python doesn't have a char delineation to strings. And so strings can be defined through both, whatever you find more fit. That said, strings behave very similarly to lists, which mean that in order to access certain parts of a string, you don't necessarily have to convert them to a list. And so you'll find that many different list functions may also work with strings. Accessing a letter in a string is pretty much the same. As we can see here, string 1 at 3 is E, 0, 1, 2, 3. So that's correct. And we can also slice strings in the same way. So string 1 from 5 over is text, as you can see here. String concatenation is actually performed through a plus operator, so an addition operator. So say, for example, we wanted to add, or we wanted to put string 2 at the end of string 1, we could do something like this. However, you can see some other text concatenated to some text doesn't have a space in between it, which is why originally it had a space. There are also other ways to concatenate strings, for example, through the join operation. And as we get further along, I can go show how joins can be useful in relation to string concatenation. Conditionals. So in Python, conditionals work basically the same as any other programming language. The biggest difference is that the if, elif, else loops and other functions like that, they are indentation. They're reliant on indentation rather than on brackets in order to delineate these different statements. So for example, here we can see if my variable is less than 0, we'll print negative. If equals to 0 is null. And if it's more than 0, we'll print positive. There are no brackets to separate these, like in other programming languages. The only way it will know is through an indentation, which is why if you wrongly indent your code, we get an indentation error by Python, as it expected an indented block after the if statement. That said, conditionals work basically the same way as they do in other languages, including having else statements. So if this statement is false, then and this statement is false, then we land in this final statement. We also have else ifs, which means that if this statement is false, then we essentially analyze if this statement is true. And if not, we end in the false statement. If we print this, we can see that it landed in an else statement because my variable is 5 and 5 is positive. Next are loops. So loops are ways to execute a block of code multiple times. So for example, we have an example of a while loop here, as well as a for loop. And these are the two types of loops within Python. And they work the same way as they do in other languages. While you define a while loop as a while and then a condition. So for example, while my variable called I is less than the length of my list, then we'll print my list at an index of I. If we print this, we can see that it prints 86,400, 4, 3, 2, and 1. Despite only really having one print statement, it has printed 5 times. For loops, basically the same way. However, some important distinctions is that we use range instead of defining a for loop, such as for int I equals 0. Oops. I is less than, I don't know, j dot length I plus plus. Most of you may be used to this for loop syntax. However, you may be wondering what happened to that type of for loop syntax in Python. Well, all of this has been replaced by a range function. And some of the variables in a range function is optional. So for I in range, and if I wanted to do something like this using range, I would do 0 as the first argument, a length, which is j dot length. But we know that Python objects or Python lists don't have a length property, so we'll do length of j, comma, and then 1. 1 is our step because, as you know, I plus plus is equivalent to I plus equals 1, or I equals I plus 1. So this is the equivalent of that. Oh, I don't know what happened to that. So this is the equivalent of what you see above in other programming languages. But what's interesting is that a range function, the start as well as the increment is optional variables. It will, if you don't provide them, it will always start at 0 and it will always increment by 1. So we can essentially omit most of the things that we'll find in a normal for loop or for loop declaration by just giving the length. And so we can see here, does the exact same thing. We do have for loop shortcuts, so we can print things like for element in my list, similar to, I believe, other programming languages have this functionality too. I think C# does. And so you can, instead of like indexing through a iterable, so for example, a list, you can just say for a variable declaration in my list, I'll print that variable. So we do that and we get the same thing. And then lastly, before we get into class and objects, we have functions. So functions are defined as means to separate out code into different blocks and perform more precise actions. And they also allow us to actually reuse code that may, say, for example, if you're writing a piece of code, you may have to rewrite or redeclare the same type of code over again, which means, for example, if I write a square function, that means I can just call a square on an object that I pass into it rather than having to copy paste the same line of code in order to do a square function. So as you can see here, we have two simple functions. We'll multiply 3 by 2, which is 6, and then we'll square it. And as you can see, we get 36. Python has a different way of declaring some arguments, in that you can have default arguments like what you saw in length, where the default arguments were the start as well as the increment, and that's why they're optional. And with these default arguments, you can also explicitly name the arguments within a function. So for example, here we could say that A is equals to 3 and B is equals to 2. But say, for example, we had, for whatever reason, C, and we make that equals to 3. Oops. We can see that we have here 36, but then if we do something like this, it still takes 36. We can define a C as 7. And let's actually do something with C. And now we can see that it has multiplied everything plus the C variable. But if we don't name out C, we can see that it still multiplies A, B, and C with the default value of 3. All right, that was a very, very quick introduction to like Python basics, as well as just glossing over some of the differences between Python and some more common object-oriented programming languages. I just wanted to know if people had any questions with these or things they'd like to know out of everything that I talked about before I get into class and objects. All right, I'll take silence as a we're good. So an important concept in most, or not most, but all object-oriented programming languages, including Python, is class and objects. And you'll find that in whether or not you're programming in TensorFlow or in PyTorch as you're creating models, class and objects become very important because you're going to be passing objects from one function to another and reusing these same objects as you manipulate them. So in Python and other similar object-oriented programming language, a class is a means to define an object. So an object can have associated properties that are attributed to it, and it can be passed around to different functions. So here I define a person object, and it has the properties of name and age. If I go ahead and print person.name, I get DAX, and if I print person.age, I get 25. However, defining a person like this is not actually very useful, and it's because not every person's name is DAX and not every person's age is 25. And so if you ever had to like change a name, you'd have to copy this class, define another class, and basically put the same attributes. What if we didn't want to have to do something like that? Then we'd essentially define a class, but we'd give it an init function. So essentially a means to construct a class, or essentially a constructor, if you know other programming languages. So with this init function, we construct or we can assign values to the different internal variables of this class person. So you would define that through an init function, and Python knows to read an init function as a constructor. And so with init, what I'm doing now is that self is a way to refer to this object, the specific person object. We can set self.name to the name that we pass it. So the name that we're passing for an object named mentor is Dax. And we can set self.age as the age that we pass it, which is 25, into mentor. So we can print mentor.name and mentor.age, and when we run it, we can see that. So for example, if I wanted friend equals person, Barbara and 57, we can see that unlike doing it in something like this, where it would change the person class entirely, if I run this, mentor is still the same. However, friend, we now have a friend that uses the exact same person class without having to redefine or essentially do something like this, right? So that's really nice because you can reuse a class definition with that. Go ahead and do that. And with classes, and I've just extended this class to have a function. With classes, we can have different functionality that act upon these internal variables. So for example, if I wanted to have like a birthday functionality, I could define a new function called birthday, add self into it, self being, again, the object that it's referring to. So if this was the mentor object, this was the mentor object, then self would refer to mentor with Dax and 25. If this was the friend object, then it would refer to another person, Barbara and 57. We can see here that I print mentor again, and it's going to say 25. But when I do mentor.birthday, it will internally add 1 to my age, and now we have 26. We can also see that if we print friend.name and friend.age, we can see that friend is still unchanged. However, if we do friend.birthday, oh, sorry, I need to do this again. So the reason why that didn't work is because person had this definition and not this definition of a class. So I do have to run it again. As you can see, if I do friend.birthday and I print mentor.age, my age doesn't change. But if I do friend.age, we'll see that I'll probably add twice. Or no, it added once because I redefined Barbara again. So it added once to friend. And now, so when I print friend.age, it's now 58. Are there any questions with class and object? We're actually going really slow, so I apologize to everyone if you already know how to program. All right. So we'll go very briefly in terms of NumPy, just because, and Pandas, because I think both are pretty important as you're going along in terms Python programming. So NumPy is a very important data type / object that you will encounter. And that's because it's the primary library in order to manipulate things called multi-dimensional lists. So multi-dimensional lists are essentially a list within a list. So you can say a 2-dimensional list is a list within a list, so 2 dimensions. And a 3-dimensional list is a list within a list within a list. So for example, if I have a 2D list defined as empty, and then I have essentially want to make a 2-dimensional list that contains every letter for every word inside this string variable, then we end up getting something like this. ORD, by the way, is a means to turn a piece of text into a numerical format, or rather a character into a numerical format. So as we can see here, H has a value of 72, E has a value of 101, so on and so forth. Rather, capital H has a value of 72 and lowercase e has a value of 101. And we can see that this is a list representing this word in numbers within a bigger list, which represents all of the words within the string. So this is a 2-dimensional list. A 3-dimensional list is something that I want to talk about at least a little bit, because images in particular are in 3 dimensions. Why? Because an image has rows, columns, and RGB values. So one list contains all of the rows in the image. So let's say row 1, row 2, row 3. Within that row list has all of the columns in that image. So column 1 of row 1, column 2 of row 2, column 3 of row 3. And then you also have RGB within those columns. So you have R of column 1 of row 1, G of column 1 of row 1, so on. And so you can see that it's actually a 3-dimensional list, or a list inside of a list inside of a list. And so what I've done here is very simply, I uploaded an image called v.png. And if I print v.png, we can see that there are 3 brackets at the very start. And as we can see in this to-do list, there are 2 brackets at the very start. So we know that we're probably interfacing with a 3-dimensional list. We can see that here are the RGB values for row 1, column 1. And then you can see ... because it truncated that print statement. And then it stops with 2 brackets, which means that this is the first row. So on and so forth until we get all the way to the end, which is these are all the RGB values per column per row in this 3-dimensional array. So we can define arrays in various different ways. You can pass in a list. You can pass in a list of tuples. You can pass in all sorts of different objects and then just define their data types. You can also make a array of just zeros. So as we can see here, D is just an array of zeros. You can also create a constant array. So for example, H is an array of a size filled with 7s, so on and so forth. One thing to note, especially if you're going to use functions such as np.zeros or full, is that this first variable defines the array shape. Unlike Python lists, where you can continuously append to a list because the list is of a dynamic size, NumPy lists are not dynamic, which means that like other programming languages, you're going to want to explicitly define what the end size is going to be. So as we can see here, we define the end size of D to be 3, 4. And what that means by 3, 4 is that we have 3 rows and 4 values per row. If we wanted to add another dimension, so we have now two values per column. Oh, sorry, this is the problem with running things out of order, is that you can do stuff like that. Do this again. Now we can see that D has turned into a three-dimensional array from a 2 dimensions, and now we have two values for 4 columns for 1 row, as we can see here. Or sorry, 3 rows, as you can see here. All right. Last thing, I only have 7 minutes, so I'm going to actually just run through this really quickly. You do have ways of which you can do array or matrix subtraction, matrix addition, division, multiplication. There are a lot of other ways you can manipulate arrays. You can reorder inner values through accesses, etc., etc. All right. Last thing is pandas. And so all I want people to take out of pandas is a way to read tabular data. And by tabular data, I mean things like Excel spreadsheets, which are tabular. Data frames are 2-dimensional. And by that, I mean they have a row and a column. And in each row and column, there's a cell, and a cell may have a value. So very much like an Excel spreadsheet where you have rows, columns, and cells. There are multiple ways where you can define your data frame. So for example, I have row 0 and row 1, column 1 and column 2, and I defined it as this way. So column 1 has 2 values, column 2 has 2 values, and you see I created a data frame this way. The most common way to define a data frame is through pandas.dataframe. So note that I import pandas as PD. So pd.dataframe, and you can delete this to create an empty data frame if you want to. You can also define it as a list of dictionaries. As you can see here, column 1 is I, column 2 is I times 2. I append that to a list of rows, and we have this. You can also load a data frame through a file. So you can put an example.excel file and read from Excel, and it will create you a data frame, as well as a CSV file through the read CSV function, and it'll create you a data frame. This may look very familiar to you all, and that's because I downloaded the Excel sheet as a Excel file, or the summer spreadsheet as an Excel file. And as you can see, when I read it, I see a summer data frame, and I display it through Jupyter's Notebooks display function, which does display pandas objects in a proper tabular format. And with that, you have very common Excel functionality, such as adding a column. So here I just have some logic in order to generate the list of first names. And then I essentially set a first names column as my list of first names. And we can see now we have a new column here called first name. You can also filter data through a conditional. So for example, Vigor summer students, and I say summer DF where, and I use brackets kind of like indexing in a list, where the project column, right? I have to change it into a string just because some people have it as not a number, which is not a string. As a type of string, string contains Vigor. And so with this conditional, I can essentially display just the Vigor students. And so here are the results of that. And then there are some other common functions. For example, you can sort values. So here I sort the values first by project and then by name. And we can see that L is the first project letter that's closest to A. Then M is right after L, then P, T, and then V makes sense because V is one of the last letters in the alphabet. And we can also see that it's arranged by sorted by name as well. Although Decilodesima is out of sort just because my project has a lot more values than the US figure. So that is the reason for that. Okay, we have 2 minutes. Sorry for like going through the really basic parts of Python. Hopefully this was okay enough, like glossing over what Python can do, some of the differences between Python and other programming languages, at least for the very basic fundamentals of programming, as well as some basics of both NumPy and Pandas. Are there any questions that people wanted to ask? I am guessing.
I just generally
Oh.
wanted to ask what I missed
Yeah.
in the last meeting, if you could like TLDR that.
Oh,
That could
sorry.
be like a end. I was just gonna generally ask what I missed last week's meeting, but that can be like a very end of the meeting when everybody else leaves question.
Oh, okay.
Because not everybody everybody that was there doesn't need to hear that again.
Yeah. No worries. Dr. Liang, if you'd like to stay after the meeting too, because I don't quite remember all of the things we talked about last week.
Okay, no problem. Okay.
Alrighty, everyone. Yeah, and sorry I couldn't get through this, but I guess everyone can just look at this Intro to ML notebook. Everything that I talked about here should get you close enough to everyone basically understanding what is going on within this notebook, including having fit functions, defining some objects, having a fit function within that object, so on and so forth. So, yeah.
Okay, thanks everyone. And next week, please, I think it's Armin and the deck to take the leadership to have everybody to give like a plan, okay, the summer plan of the prepare. So I hope next week everybody give like at least 5 minutes, okay, talk about what you just intend to achieve. So next, how about your team? Your team can make it next meeting. Everyone
What do you mean by? Oh yeah. My team.
How about your team? Every member of your team should give a 5-minute talk about the objective or plan.
Sure.
Okay.
Yes.
So any questions for Dr. Wu or me? Any questions? No? Okay, great. Okay, and I will see you guys. This is the see you guys next Monday, right? Okay, thank you. Dex, you want to talk with me?
Yes, and other people who want to ask questions, feel free to stay. If not, see you next week.
Okay, thanks.
Okay. So Dr. Liang, because I kept you here just because I didn't know if you wanted to talk a little bit about LiDAR, which I believe is what David is working on. So in terms of what we talked about last week, it was mostly logistics as far as I know. However, I think because you weren't there, I don't know, Dr. Liang, if you like wanted to omit or just omit like some information about LiDAR. I also don't recall anything, or I believe you talked about LiDAR, but I forgot what you said about it.
We have it, yes. The LiDAR project, as a matter of fact, is Armin's team. I think it's Davey. I think you can talk, you can set up a meeting with Armin, which is another team leader. We have the 2 leaders now, Dex and Armin and VG. We have 3 leaders. So VG is working on the transportation management. Dax is almost like almost everything, but he focused on the transportation and also particularly medical device. And Armin is working on the LiDAR. Yes, I think I think you can set up a meeting. So the LiDAR is we try to just use the reinforcement learning to control the to optimize the data acquisition. Don't forget the keywords is the data acquisition. The second keyword is multiple LiDARs. We call it swarm. So we are using we try to gather the information, obtain the situational awareness in the shortest time. So that's the work we are doing. So, and I can share some like the PPT with you, or you can, before we go ahead, maybe you can share some, you can set up a meeting with Armin. It's okay?
Yeah, I was planning on emailing Amin because I just the past week I've been super busy with my job. But I wanna like keep doing the project work and I want to study and be a part of everything. I just needed a week to get adjusted. I didn't get an email from him, so I hope that's a good sign that they're setting up things on their end.
Last meeting, you missed the last meeting, right?
Right.
Yes, that's why, because the last meeting, we just assigned each student a lead, like the mentor or team leader. So,
okay.
Yeah, I think that so your team, for your research interest, you should go to the Armin's team.
Okay. Okay, yeah, I'll be sure to do that. Yeah, I think from there, I just wanted to make sure that yeah, that I was like in contact with the right people, that I would know who to talk to. And I just want to apologize again that I wasn't able to make it last week.
No problem.
Yeah,
Yes.
I was just in a lot of meetings because it was my first day at this job.
You got a job?
Yeah, I managed to get a job with a company called Freightwaves. It's an internship right now for about 12 weeks. Yeah, so thank you. I should have enough time for both the job and the research. It's just going to be about time management for a little while and really working hard for a bit. But yeah, everything should be good. I should be able to time share everything. I don't usually have meetings from 2 to 3 p.m. But if one week I do have a meeting, I'll let you guys know. And if possible, I can just look over the recording of the meeting and email questions to Amin, or if I have a question for Dr. Liang or Dax, I can email you guys after the meeting, if that's okay.
I see. Yeah, LiDAR, you have to learn two techniques. The first one is reinforcement learning.
Yeah, I've been learning, yeah.
Okay, reinforcement learning, and the other one is the signal processing.
Okay.
Yeah, so this is two weapons. These are the two weapons.
Okay, I'll write that down.
Reinforcement learning plus signal processing. Okay, that's it. So you take a look at and set up a meeting with Armin.
Okay, thank you so much.
Thanks.
Have a good one. See ya.
Thanks. Bye.
Dr. Liang, if you mind staying a little bit.
Yes, I will say.
Okay. Okay, so
I need to stop recording.
oh sorry. Did you? Oh yeah, maybe you should stop